And that's the important thing. We're just looking for the number. So since we're just looking for the number, what we could use is Descartes' rule of signs. So to use Descartes' rule of signs, first thing you're going to do is put it in your descending order. So we'll have a 15x to the fifth, let's see, minus 5x to the fourth, minus a 54x cubed, plus an 18x squared, plus 27x minus 9. Okay, so remember Descartes' rule of signs says the number of sign changes minus an even number is the number of positive real zeros. So positive real zero, yeah, I just want to make sure I said that. So one sign change, 2, 3. So we could say the number of positive, oh, let me just write that. So real zeros. Again, we don't know what they are. We just know the number of positive real zeros is 3 or 1, right? So you take the number of sign changes, which is 3, and then subtract an even number, which would be 2, and then we get 3 or 1. Now, if we want to be able to find the negative real zeros, we're going to do f of negative x. So if we plug that in, again, I'm going to simplify on the fly so we can figure that out. So that's a negative, so that'd be a negative 15x to the fifth. That'd be a positive, so that's a negative 5x to the fourth. That's a negative times a negative would be a positive, plus a 54x cubed, that's a positive, plus an 18x squared. That'd be a negative 27x minus 9. Okay, so now the number of negative real zeros is 1, right? And you can't subtract an even number. We can't have like negative number of zeros. So now we got to understand the fundamental theorem of algebra, which states that we're going to have the number of zeros, real or complex, is going to add up to 5. Okay, so we definitely have 5 zeros. Now, let's pretend we have 5 zeros. 3 or 1. 4. Wait a minute, something's happening. Oh no, I'm sorry. That's 2. I didn't check my work. That makes sense. Okay. Is 2 or 0. There you go. Okay, so let's go ahead and rework it. So we could have positive, we could have negative, and we could have complex, right? And that's the question, that's the answer that we're looking for right down here. So the number of positive is going to be 3 or 1. So we could have 3 or we could have 1, right? For the number of negative, we could have 2 or 0. Now again, remember our total number is 5, right? We have to have 5 zeros because that's the fundamental theorem of algebra. It says, fundamental theorem of algebra, we have to have 5 zeros. Okay, so if I already have 3 positive and 2 negative, how many complex zeros am I going to have? 0. If I have 1 positive and let's say 2 negative, right, then I could have 2 complex. And if I had 1 positive and 0 complex, I could do it something like that. Then I could also have 4 complex. So the number of complex, we don't know which ones what they are, but we know the possible number are 4 or 2 or 0. And I know this is a very complex topic for a lot of students, and just going through it kind of quickly is probably not doing it much justice, but hopefully this kind of like understands at least the process. You got to find the number of positive, got to find the number of negative, and then you got to find and then you kind of go through all the situations based on the fundamental theorem of algebra.